Sunday, April 19th, 2020. This is Darren Marchant with American Nomad News. It's an interesting subject we have to discuss today. On 3rd of February 2020 BX-12 passed 4.36 million kilometers. That's 2.71 million miles. Roughly, to put that in perspective, that's about 11.35 lunar distances from Earth. During its close approach to Earth, the asteroid approached Earth at a rate of 57,000 miles per hour, roughly. And its apparent visual brightness peaked around magnitude 15.7. It's too faint to be seen with the naked eye. At the closest approach, the asteroid's apparent motion in the sky was 1.2 degrees per hour and was in the constellation Cetus, apparent magnitude of 16 and angular separation of 20 degrees from the Moon. What does this all mean for us? This is actually not an unusual incidence. There's a website on NASA that talks about close approaches to the Earth, and there's quite a few listed on there. There's a whole class of asteroids called NEOs, it's near-Earth objects. These objects regularly cycle around the solar system such that they come in close approach to the Earth on a regular basis. Asteroids didn't used to be considered all that important by astronomers. Astronomers early on were looking for stars and planets. They wanted to find large objects, and they really didn't think asteroids were important. Well, geologists have, over the last few decades, have been discovering more and more evidence that asteroids are incredibly important to every aspect of big science. From the evolution of animals on the planet to the formation of planets, there's a lot of talk about being able to get to asteroids in order to find out what were the conditions in the early solar system, because a lot of these rocks, they're in a frozen vacuum a long ways from the sun, and to get to one of these could tell us a whole lot, put things in perspective for us. There's been a few missions to the asteroids. It was an impactor mission. There have been a few missions trying to land on asteroids. Some of these missions have actually been built and launched, and things happen. A lot of missions have been discussed, hardware worked on, designs built, but not really gotten launched. So it's kind of a churning little side thing. There's also several companies around the world that are registered that their main goal is to mine asteroids. There's even a country in Europe that talks about changing their banking laws to become the Switzerland of asteroid mining. So asteroids are becoming a very important issue. They're also an opportunity. Not too long ago, this asteroid came right by our planet. Only roughly 11 and a half lunar distances. That's pretty close. So here's a what if. What if we take some off-the-shelf hardware and we look at the designs that have lasted the longest? There's a couple of probes that are actually outside of our solar system. They passed Pluto and they're way out there. But they're not reporting a lot anymore because they've been there for a long time. They were designed back in the 70s. And there's only so much that you can get out of them. So here's a what if. What if we design a new mission, learning some of those lessons, and we put LiDAR, radar, radio telescope, optical telescope, infrared telescope. Don't put super expensive ones on there. Go for the medium price list, Put an optical telescope maybe 12 inches in diameter, right? Build a lander and mass produce it so you can get lots of iteration out of your setup and design. Kind of like Elon Musk is doing his mass-produced satellite launches. Drone swarms. Only these are designed to land on one of these near-Earth asteroids as they approach the Earth. You can park them out by the moon. Just park them out there. Have them prepped and ready and parked in a constellation, in a tight grouping, maybe even lumped together. And when one of these asteroids comes by, right? Okay, not to go like this, but like this. Okay? So, when one of these big asteroids comes by, and you've got this collection of mass-produced probes that are lightly attached to each other, okay, maybe magnetically or something like this, and they're all fueled up and powered by electric propulsion, and they have liquid fuel landing rockets, and one of them separates off, right? And this one flies out, right? Times it's, here's this big rock coming through, and here's this other one, and gets in a cohesive motion with it, right? They pick a spot and land on it, and they hitchhike, stay on the asteroid. It's not a sample return, it's nothing like that. It just sits on there and takes advantage of the momentum built up that's stored like a battery in that massive object. You've got this big object, right? And here we go. Here's our asteroid, right? And here's our little lander, and it lands. Plunk. And the lander's tiny, right? Maybe it's the size of, a VW buck. And this thing's 3 blocks in diameter. And this thing has a tremendous amount of mass compared to our little lander. And that mass is already in motion. Conservation of energy, all that kind of jazz, right? And its orbit, its trajectory is already going to be way out in the solar system and back around again. Okay? And you build it to be a server, an observer, and not so much to observe the asteroid it's on, although you certainly, could do a little along that line, but to be a hitchhiker, to take advantage of the thrust of this asteroid. And we could pick asteroids more by the fact that they come close enough to us than by being a particular group like NEOs or others. There was a asteroid that came through our solar system that we were fairly convinced was not from our solar system. Tremendous amount of savings of propulsion if we'd been able to land a probe on that thing. Just drop a probe on it, let it fly off. Design it to be really good at communicating back to Earth in pulses if necessary. And the nice thing is you can make this thing pretty bulky. You can put a lot of equipment on this thing. Put a big battery, big communications array, a server that can transport packages of data, And you can put them on lots of rocks. Just put them on these rocks as they fly by and let them be little, and especially some of these asteroids are quite dark. They have an albedo that absorbs more light than it reflects. It makes them really hard to see. Why not have something on there that flashes a light or a radio signal, something that's really easy for us to see, and wouldn't have to take a whole lot of energy because it could flash periodically. We have similar kinds of things in ocean navigation. We have buoys with their blinks are on certain cycles, so we know which buoy we're looking at because we're looking at the map. These kinds of devices could be significantly useful. But on top of that, it could keep a bunch of guys working. You know, if we're manufacturing probes like this, and we can justify the dollars on the benefits that we design into them, and the cost savings of propulsion, of being able to send these things around the system, we can even mass produce portions of the lander, and customers can come along later and customize and add on things and change things without having to. There's actually a company that already does something like that. So you have a foundation, a booster that's got your basic propulsion and all this kind of stuff and power and everything, and you can put module systems that you can change and flop out and mass produce each and save a lot. And save a lot on fuel, landing them on there. But what's the big ancillary Earth benefit? You keep STEM specialists busy. You keep them working, doing things that are justified and good, and later they'll have the skills to do things that we want to do when we find out that we want to do those things. They can feed their families, they can pay their bills, everybody wins. This is Darren Marchant, reporting for American Nomad News. Let's put America to work again. Let's go out into space in a big way. Let's make a bunch of money doing it. Thank you very much.